All right. Hello, everybody. About that time again. We're gonna have a small crowd this tonight, which is okay. I'd show my face tonight. Be nice. A lot of what tonight does kind of overlaps into tomorrow, so I was trying to be really careful to not just do the same thing 2 nights in a row. So I tried to fill the gaps in tomorrow with the Cooper chapter on some of the things we didn't cover so much in depth tonight. Just try and make it a little bit easy. I had this all ready to go a while back, and then COVID struck, but I'm feeling a lot better. We all are in the house and ready to start studying again. Don't forget to check our YouTube channel. All the videos go straight there. The Cooper and the behavior lasting change, and then all the special guest speakers that we've had so far come in, they're also posted as well. And of course, on the Rockin' Facebook page, we have all of our other good stuff too. We're in good shape. So let's go ahead and get started. I probably have some stragglers, and that's okay. And people that are going to come back and watch us again, thank you all for studying with me. I really do appreciate it. Helps me more than y'all realize. This week in the behavior lasting change and the Cooper, we're going to dive into data and visual inspection also. We're going to look at behavior recording systems and how it's important, how it's implemented, why it's implemented, and the uses for it. According to Meyer, our basic recording staff are people in OBM, services, businesses, organizations. We also use healthcare settings, and we also use our schools. We also do our home healthcare. We do our clinical work, and of course, a various variety of settings as well. But we have a lot of different people. We have a lot of different sources, and our data is what we use to make our decisions. Cooper is going to be the same way tomorrow night. That data collection is driving force. It comes from a variety of sources, but that's why we try so hard to make sure it's valid and accurate to lead those reliable results. Because if it's not accurate, it's not reliable, it's not valid, it can kind of sway us in the wrong direction of what we're trying to do, what we're trying to accomplish. When we schedule behavior recording, we're also looking at validity. The validity is the method measures what it's supposed to measure. Are we measuring what we're supposed to measure? Accuracies we're looking at, are we both using the same measurement tool and getting the same results? When we schedule our behavioral recording sessions in a way, we want to collect data that truly measure what we're supposed to measure. I think this has been a big deal for me with my settings, especially for my supervisor, where I go into a setting and I'm observing and I'm recording all this information, and she's done a very good job of streamlining me and saying, okay, this is what your baseline information has said, this is what the teacher and the para and everybody else has identified as problem behaviors, And that's when I need to schedule my recording sessions, my observations to collect those behaviors, those specific problem behaviors. It's also important to, you're also confirming or you're unconfirming those sources as well. We're looking at times a day, days a week, certain activities, certain weather conditions, certain assignments, certain tasks, certain activities. We're looking at a multiple of conditions. We're not just going in the same time every day or a couple days a week and saying, bam, we got what we need. We're doing different days. We're looking at, according to our previous data, what was the big days, what was the worst days, what was the biggest activities. But we want to have a myriad of different observations to look at those different things. Remember, we're trying to establish a pattern of behavior. That's why it's important. Does it happen on Mondays? Does it happen on Wednesdays? Does it happen on Fridays? In a preschool setting, does it only happen during circle time, center time, outside play? Does it happen during certain academic subjects? Is it with certain specific teachers? Does it happen with Miss Holland, but doesn't happen with Miss whatever? Does it happen with the para, but not the teacher? Does it happen with the teacher, not the para? Does it happen with the RBT and not when the BCBA's in the clinic? You're trying to establish a pattern of behavior when you do your recordings. We also want to look at the frequency of recording. If there's a concern with increasing or decreasing the rate of behavior, we need to use the validity-defined objectives across standard time periods. When we look at duration of recording phases, we need to look at how long we maintain baseline for each intervention phase. Depends on the data themselves. Our baseline data, if it's stable, if it's showing stability, we can move on to the intervention. One rule of thumb, depending on urgency to implement interventions, is to continue to assess performance until the data becomes stable according to your pre-specified definition of stability. We have to have a stable trend. I know we had a question in our group about 2 data points in the baseline, but 3 establishes that stable trend. Data collection guidelines also look at definitional detail, determining how specific the performance measure will entail. That kind of comes right down to also your measurable and your measurable and observable definition. You need to be specific in what you're looking for. What is the behavior being observed? What is the data that needs to be collected? And that's why it's very important to be very specific when we're looking at that as well. What's the unit of analysis? What unit size will be analyzed? How refined does the analysis need to be? What extent do you want to combine data for purposes of graphing and analyzing? What unit are you going to use to measure? Graphing guidelines, graphic representations of data are primary basis for monitoring whether systematic alterations in the behavior or behaviors of concern co-vary with given behavior change programs and for deciding whether any procedural changes are indicated. Visual inspection is a big thing. It's just if I put a graph out, showing my data, showing my research, showing my interventions, showing my whatever, and just looking at it with a visual inspection, does it determine whether the performance measure or its trend or its degree of variability systematically changing while the intervention is in place. That visual inspection, which we're going to talk about later on from my coursework, do we have a level? Do we have a trend? Do we have magnitude? Do we have, what's our proportion? We want to look at all those things, but by looking at that data, that visual inspection, it's going to kind of help tell us a story of what's going on with that information. Cooper tomorrow, but I won't go into too detail, just mostly the different types of graphs with multiple data points. But a line graph, it's most used frequently in ABA. It can also be judged upon as an equal interval graph. We're adding and subtracting equal intervals. We'll also talk about that a little bit more tomorrow night also. But just your basic line graph, you have your x-axis and your y-axis. Your x-axis is your Abisca, and your y-axis is your ordinate. Rogue ABA has a great little tool to help me remember, and it's Axio. A-X-Y-O, Axio. Helps me remember those parts of the line graph. This is pulled from one of my things, and I changed the name and all that. I put the little boxes in there to kind of help with the visual inspection for somebody else. But the idea behind it is to kind of show, the trends, the levels, and the different spots in my line graph. Get back here. Bar graph is another graph that we also use. Bar graphs do not represent response sequences. They're basically used to compare things. They're compare discrete sets of data. One thing versus another, and we can compare it side by side. Or you're unconfirming those sources as well, looking at times discrete sets of data. And then we have our steps in graph construction. Just kind of pretty simple deal here going on here. I try to pull it from my coursework and from the Meyer book as well. You want to have your X and your Y axis. You want to make sure you label your units. You want to connect your dots. You also want to have your phase, your condition breaks to show your different phases. You also want to have your phase labels. You want to have your descriptions. Make sure you have your labels. Everything needs to be in there. I'm gonna get to cumulative records. I know we had a topic on our page a couple days ago about the two different types, the overall response and the local response rate are the two different types. But a cumulative record also it's a ratio type of graph. It's a ratio chart. Instead of the equal interval graph where it adds and subtracts, we're multiplying to show a long period of time. It displays the rates of the behavior in the form of changes in the slope of the curve of the response patterns generated as a function of the conditions in effect. The steeper the line, the more rapid the response rate. The cumulative record also permits one to view at a glance the total number of responses accumulated during the recording periods, as each new measure is added unto the previous total. It has an advantage of revealing at a glance the frequency of responses over time. That's why it's a ratio graph, because it looks at rate. A stair acceleration chart is also a type of this graph as well. Also looks at over time versus equal intergraphs. We're looking at the line, the bar. I forgot how the cumulative part in there. But the big difference between the equal and the ratio, like I said, is it's over time. And we're multiplying versus adding those equal parts. Stair acceleration chart is a variation of the semi-logarithmic chart, which shows proportion or relative instead of absolute changes in behavior. And then the equal interval as well. All right, here's the most important part of tonight, and where I want to spend more time on. I'm kind of going a lot faster than usual, and I feel kind of off my game a little bit since I've been out, but it's the visual inspection piece. And I try to pull a lot of my stuff from my coursework, and I definitely gave credit to where it's due at the bottom of the page. We have a whole PowerPoint slide devoted to visual inspection, and visual inspection is important. It's key. When we did research, article reviews and critiques and all that stuff, A big part of our grade was doing a visual inspection on the graphs that were provided in the research. So I pulled this PowerPoint, or the information from it, every time I pulled one of those graphs, every time I pulled one of those papers and broke it down. And it became quite helpful to me. And that's why I want to share it tonight. Visual inspection is confirmation of experimental controls demonstrated through the interpretation of level. Our levels are basically our mean performance through the phase of the study. It's our average. Some studies will tell you the average, but you could also put a condition line in there to kind of get an idea of the level as well. The levels of behavior should be different between conditions. It shouldn't be the same all the way through each phase. This graph was taken from the coursework, and I added those level lines were the same thing from the work as well. It's a straight line all the way through, trying to show a mean performance for each phase of this study. Look at trend. Trend, where the data is going. Is it increasing? Is it decreasing? That's why I have these lines kind of going at a slope either down. So if we look at our baseline, our trend would be it's decreasing. It started off and then it started to decrease. You could also say our next baseline has an increase as well. Behavior should be trending in a direction that demonstrates control by the independent variable. Your trend should be showing the direction of what you're trying to do as well. If you're trying to use something to decrease behavior or increase behavior, you want your trend to go in a direction that shows your IV is working. Stability or steady rate responding is often desirable. We look at our baseline here, we do have a little bit of variability in our trend. If you look at faded bedtime response cost in the first part, we do have a more of a still a little wild, but we still have a more stable trend as well. It's decreasing. And then our final intervention, except for that one little spike right there, we have pretty much a slight decreasing trend. Trend, here's another view of trend also. This is kind of the perfect world trend. All of our data points are going in one direction, and all of our data points are going in the opposite direction. So obviously our baseline shows an increase, and obviously our intervention shows a decrease. Like I said before, we want it trending in a direction that shows the independent variable is working. We'll look at immediacy. This is also taken from the coursework. This is following the onset or withdrawal of an intervention. So if I look at this little spot right here where my baseline is ending, the data point is up, and then there's a decrease when the intervention started. And then when I go back into baseline, it goes up, then it goes back down. The more immediate the effect, the better. So the bigger the gap, in this case, is showing that my intervention is working because of the big differences in the big gaps. So this study right here does have a larger immediacy happening. And then this was kind of a tricky subject for me and several others in my coursework with proportion. There should be a graph here, might be the next slide. Proportion of data points is basically, you're going to put a horizontal line. And if you're looking for an increase or a decrease, we're going to look at either above that line or below that line. Of course, the non-overlapping points, that's what we're going to look at here. The less, the better. The more, it's not. So we're trying to go for the less overlap. 9% higher that we're trying to root for here. And of course, 70 to 90 is good too, because it also shows the treatment's effective. But you want to shoot for that 70 to 90 range. And this is what I was talking about with that line. Um, in this case, I went from, you can go from the highest or the lowest. Take your highest or your lowest point on your baseline and you draw a horizontal line across. So in this case, if a decrease, we're looking for a decrease in target behavior anticipated. We want a decrease in our behavior. So we're going to look at all the points that are lowest, that are below. So in this case, we're going to look at everything below that line. If I went to the highest point on the baseline, we would look at everything that was above, because we're looking for an increase. But in this case, we're looking for a decrease based on my example. And we're going to count the number of points in the intervention phase that are above, or in this case, below that horizontal line. And then we're going to divide by the total number of data points. So in this case, we got 1, 2, 3, 4, 5, 6, 7, 8. There are 8 spots below, because based on where our line is, we're looking at all the data points that are below it. So it's 8 divided by the total number of data points in the intervention. So it'd be 8 divided by 10, 12, 14, 15. So it'd be 8 divided by 15 would be our PND. And of course, we multiply by 100 to get our percentage. This, like I said, this line was drawn looking for a decrease in target behavior. That's why it's the lowest baseline point. Magnitude of the dependent variable changes. This is the degree of change from one condition to the next. The more, the better. So when we started our baseline, it started out, on this graph, it started out a little bit below 10 for minutes sitting in circles, whatever, I guess, minutes sitting in circle time. So they're right under about 8 minutes in minutes sitting in circle time. After our second intervention phase of using the social story, not really sure happening here, because social stories don't have a lot to go with it, but nonetheless, at the end of it, our magnitude shows a significant increase. It shows the more the better. Leaving our intervention phase before we enter maintenance, we show a large increase, a huge degree of change from the beginning to the end. We also want to look at consistency of data patterns. Just like Ryan said, you can go crazy with ABA, AABBA, or ABCA, and you can go crazy. But the more baseline and the more baseline and intervention phases that you keep putting in there, the better, according to this information from my professor. So the degree to which desired behavior change occurs consistently or is replicated with repeated application. The more we have that repeated application and that removal of that IV, the better this is as well. This particular graph is an ABABC graph. All right, kind of short and sweet tonight. Kind of off my game a little bit, I feel like. Just a lot of stuff happening in this chapter, and then the next and then Cooper kind of falls a little bit tomorrow night. We kind of hit back with that. That visual inspection stuff, it really helped me when I was working on my research papers and really breaking down the information in there. Tomorrow night, we're going to try to review the Cooper side of it, go over some different things as well, and we should be short and sweet also. Thank y'all so much for your time, and y'all have a great evening. Thank y'all so much.